Good day, I am TRISHA MAE Gepila, and today I will be discussing the morphologic and immunophenotypic features of normal lymph nodes. Antigen recognition, antigen processing, and lymphopoiesis all takes place in the lymphoid organs. Lymph nodes, which are round to oval encapsulated organs that serve as key sites of immunologic response, contain the majority of lymphoid tissue. They are especially noticeable at sites that have an environment interface. Lymph nodes in large groupings can be detected by draining certain peripheral locations. Internal organs are similarly serviced by regional lymph nodes. Mucosa-associated lymphoid tissue is a type of lymphoid tissue that is found directly in the mucosa of the respiratory and digestive tracts. Antigenic interaction occurs mostly at these aggregates, which drain directly into the regional lymph nodes. Thus, I will be presenting the morphologic and immunophenotypic features of normal lymph nodes that includes the cortex, paracortex, medullary cords, and sinuses. First on the list is the cortex. The lymph node is encased in a fibrous tissue capsule. The cortex is the most superficial part of the body, located just underneath the capsule. Primary and secondary follicles make up a component of the lymph node. Primary follicles are small naive B lymphocyte clumps that are microscopic in size. These cells are typically CD51 and display pan-B cell markers such as CD19 and CD20. Follicular dendritic cell meshworks, best visualized by immunohistochemical stains such as CD21. After encountering an antigen-naive, B lymphocytes undergone transformation, proliferation, and differentiation into precursors of antibody-producing plasma cells and memory B cells. The remaining naive B cells are being eliminated, inserted into the germinal center perimeter, and create the zone of the mantle. B lymphocytes in the germinal core have a distinct immunophenotype. In addition to pan-B cell markers, they display the germinal center cell antigens CD10 and BCL6, and they lack the anti-apoptotic BCL2 protein, unlike circulating B cells. The black zone, which is filled by centroblasts, big B cells with spherical vesicular nuclei, tiny nucleoli next to the nuclear membrane, and basophilic cytoplasm, are functional compartments of the germinal center. The dark zone is a hotbed of B-cell immunoglobulin variable region, somatic alterations, and high proliferative activity. The latter method enables the creation of immunoglobulins with the highest affinity for a certain antigen. Still on the cortex, centroblasts differentiate into centrocytes, which are smaller cells with thick chromatin and uneven nuclear borders, which make up the light zone after complete somatic mutations. Centrocytes with low affinity or unfit surface immunoglobulins die as a result, and germinal center macrophages phagocytize them. The presence of many macrophages with apoptotic debris contributes to the germinal center's distinctive starry sky pattern. Centrocytes with high affinity immunoglobulins for a specific antigen lose their germinal center antigens such as CD10 and BCL6 and develop into memory B cells, which create a marginal zone on the mantle's periphery. Lymphocytes from the marginal zone are medium in size, with ample transparent cytoplasm and indented nuclei. Plasma cells, which sit in the medullary cords of lymph nodes and move to the bone marrow, are the ultimate stage of B cell development. Pan-B cell antigens and surface immunoglobulins are best in plasma cells, although they do not express CD138, CD38, and cytoplasmic immunoglobulins. Next is the paracortex. The paracortex extends from the follicles to the medullary cords, occupying the space between them. T cells, interdigitating dendritic cells or the antigen-presenting cells, and high endothelial venules occupy this compartment, which produces immunocompetent T cells. These are specialized veins that allow lymphocytes from the peripheral circulation to enter lymph nodes. CD3, CD5, CD2, and CD7 are the pan-T cell antigens expressed by T cells. In the paracortex, CD41 and CD81 T cells can be detected. T cells respond to antigen stimulation in the same way that B cells do. Small lymphocytes transform into immunoblasts, which are giant lymphoid cells with vesicular nuclei, conspicuous, sometimes solitary nucleoli, and basophilic cytoplasm. Numerous B immunoblasts can be found in the paracortex. We also have the medulla. The medulla is the innermost part of the lymph node that surrounds the hilum. Medullary cords containing plasma cells and medullary sinuses make up this area. Lastly, the sinuses. Afferent lymphatics communicate with the subcapsular sinus, which is located immediately beneath the capsule in order to filter lymphatic fluid through lymph nodes. The subcapsular sinus empties into the cortex cortical sinuses, which discharge into the medullary sinuses. At the hilum, the latter converge into the efferent lymphatic stream. Macrophages or sinus histiocytes populate the sinuses. Antigen capture and processing are crucial functions of these cells.